Hi everyone, and welcome back to my channel. Today we're going to discuss another interesting topic, and that has to do with error prevention and coding. Now, previously I have addressed a very similar topic on this channel, but today we're going to look at it from a different angle. I want to start with the most dangerous mistake that I've ever almost shipped. Didn't crash. It didn't throw an error. It didn't even look remotely wrong. But it looked finished and polished in the way that it was. And this is why it nearly made it through. And if you've ever used AI to generate code, you know the feeling. You do ask for something, you get back a clean, confident, well-structured answer. It does compile, and it reads as normal. But here's the core problem. Language models are extraordinary at producing what looks correct. So when a model writes code from memory, it isn't checking against reality necessarily. It's reconstructing the most likely looking version of it. So when those two don't match, you get something that passes every glance and fails the moment it meets the real world. And, on the other hand, you might be thinking, fine, that's what testing is for, and you'd be right too. But here is the catch. You can only test for the failures you thought to look for. So, of course, testing is, reminding that testing can never be exhaustive. And you cannot write an assertion for a bug you didn't foresee. So the errors that survive are precisely the ones outside of your imagination, the ones you had no reason to suspect. The model generated them silently, and your test stayed silent too, because you and the model shared the same blind spot. And now what that nobody puts in the engineering textbooks, fatigue, which is a really, really big issue in terms of, imagine a medium-sized project with a deadline and a developer who's been at it for 9 hours already, and is probably even past midnight at that point. So this is all it takes. The signals a tired person uses to decide, yeah, this looks fine. For example, clean formatting, plausible names, familiar structure are exactly the signals AI generation is best at faking. So when you're tired, the fluent surface is enough. The mistake survives, not because the developer is careless, but because the error was built to be invisible and the last line of defense was running low. And it's important to, again, remind that that's not a skill failure, it's a structural trap. And notice what the defense actually depends on. It means staying mindful, but mindfulness is consumable. So it does run out exactly when you need it most. For example, hour 9, the night before a deadline. You cannot solve a fatigue problem with a strategy that itself requires you to not be tired. So in this case, what does actually work? And here's the shift that changed how I personally build things and how I tackle problems, even on really long and tiring days. And my advice rather starts with, don't try to out-vigilant the problem, because you will lose. A better model or more careful reviewer still cannot catch what they cannot foresee. So the move is to change what you trust. So instead of hunting for a specific mistake, you assert a property that makes an entire category of mistakes impossible. So to give you an example, I once had documentation referencing functions. Some of them were wrong, some invented names that read perfectly. And I could have never listed them all. There were like tons of them. So they didn't even know which ones were broken at this point. And when I stopped trying to find it out, I wrote one check that asserted a single property. For example, every name referenced must actually exist in the real installed library. So this is one property. It introspected the actual package and compared, and it caught every single mistakes without me predicting a single one in advance. And this is a whole trick, not to test harder, but finding the invariant that makes the entire failure class impossible. So foresight stops being a bottleneck. And that's the real architecture of safety when you build with AI. Think of it as in terms of 3 layers. First of all, of course, is generation, which gives you a draft with an unknown distribution of defects. So that's your boilerplate code right there. Then you have execution, which is actually running the thing against reality instead of against the model's memory. And that in and of itself shrinks the unknown by checking against the world. And third, you have deterministic invariants, which could be, for example, schema validation, type checks, property tests, contracts. So all of this shrinks it permanently without you having to imagine every and each failure ahead of time. And the human stays exactly where machines can't reach, and no introspection can handle that. And there's one more piece that I've learned almost by accident, but we're taught that the cure for a blind spot is a second opinion. But a second opinion only helps if the second set of eyes has a different blind spot. So that's the real reason why code review works, not because one reviewer is more reliable than another, but because what I miss, you might catch, and so on. And the trap with AI specifically in that regard is if your second reviewer is the same model as your first, it has the identical blind spots, so it agrees with the mistakes instead of catching them. And it feels like you have a second opinion when you really have the same opinion twice. So when you verify, reach for something that doesn't share the same failure mode. For example, and here it is that a tool that's right 99 times will be confidently wrong on the 100th. And that 100th will look identical to the other 99. So don't trust the generator, trust the grounding. Keep your skepticism pointed at every tool that you're using, especially the ones that you're relying on, because the moment an answer becomes true in your head instead of a probability, this is the moment when you've handed your blind spot to a machine that is very, very good at filling it. So a final advice is build a safety net first, then build the thing. Thank you for watching. As well, I'm going to leave in the description a link to the previous video that started addressing this. Hope that was useful. Hope that you learned something new today, and take care. Bye.